Falloff is a primary property of light, but it's hard to see unless you are actively looking for it. The principle is simple. The farther an object is from a light, the less light it receives. You can read a book by light from a nearby candle, for example, but not if that candle is across the room. This dimming of light across distance is known as falloff, and it follows a simple formula known as the inverse square law, which is that the intensity of light from any source is equal to 1 over the square of the distance. At twice the distance, an object will be only 1/4 as bright. At 3 times the distance, the light is only 1 over 3 squared, or 1/9, as bright. It doesn't make any difference what that original distance is, a centimeter or 10 feet. Double that distance and the light will only be 1/4 as bright. Let's see what that looks like and why it makes a major difference in your 3D images. Here's a simple office scene with just a desk and 2 walls. There are 2 lights in this scene, a desk lamp and a window that is just off to the left and outside of the camera range. The desk lamp is one of the few good uses of an OmniLight, which is just sitting at the top of the desk lamp. There also is an area light that is a window that is off to the left, outside of the viewport. And right now, the scene looks like this. You can see some of the volumetric light visible here, coming down from the desk lamp, and you can see a little bit of the window light shown here on the coffee cup, and you can maybe just make out a little bit of it here on the desk lamp, and it's a little bit bluer here in this corner of this back wall. However, neither light has falloff on it, and you can see that all of these little spheres sitting along the back of the desk are fairly evenly lit, and this light from the desk lamp here is very brightly lighting this back wall. If we turn on falloff for both lights, the scene looks more like this. Now the lights behave and look more like real-world lights. And the only change was falloff was set to inverse square, physically accurate. Here's what the scene looks like with no falloff, and here's the same scene with falloff set to inverse square, physically accurate. Once you've turned on falloff, there's just one more thing to do. Remember that falloff is determined by the inverse square law. That is to say, it's 1 over the square of the distance, and you get to determine that distance. That distance is indicated by these little orange dots on a sphere around the light. And you can see as I move it that indeed the position of where falloff start changes. All you have to determine is how far you want that initial distance to be. Do you want it to be small, or do you want it to be very large? In which case, the falloff isn't quite as obvious. Once you set falloff on a light, you should be able to see these lines which create this little sphere where drop-off begins, and you should be able to just drag on any one of the orange dots at the intersection of the lines. If you don't see the dots, then chances are you're not in model mode. You might still be in points mode, for example, in which case you won't see the orange dots. So in order to be able to control where falloff starts, you just need to come over here and select model mode. Setting inverse square falloff for your Cinema 4D lights is important for increasing the realism of your scene. And all it takes is a selection from a drop-down menu under the Lights Details tab.